here's our problem. Find the distance between 1.8 comma negative 3.7 and negative 0.4 comma negative 1.9. All right. Now there are formulas. There is a formula for this, and every book has one out there. Every textbook has one. I don't use one. I use the Pythagorean theorem, and so it's the same reason why I don't like to show the slope formula in another algebra class. Because in both cases, when people use those formulas, they're not learning anything. They're just plugging numbers into a formula, and they make mistakes with negative signs. Very easy to make mistakes. So if you think you're immune to making mistakes like that, then go ahead. But I'm telling you, I see a lot more mistakes when people use formulas that they really don't understand. They're just plugging numbers in. So you got to think to yourself, what have I learned? I learned how to plug numbers into some formula I had to look up. Or you can learn about the Pythagorean theorem and also how to avoid careless errors. Because if you sketch this on a graph, there's less chance you're going to make a obvious careless error. So I'll show you what I mean. Where is 1.8 negative 3.7? Okay, so that's about down here, we'll say. All right, now I don't have to be very precise. For one thing, I don't have graph paper, but you could be precise if you wanted to. Whereas negative 0.4 and negative 1.9, that would be, we'll say about here. So negative 0.4, negative 1.9. So I want to connect these dots, create my right triangle. And what are the distances? All right, well, in the x direction, I'm moving from negative 0.4 over here over to 1.8 on the right side. So that's a distance of, there's 0.4 here, 1.8 there, 2.2. If you do this without looking at a graph, you could easily add those together and get 1.4 rather than 2.2. Again, people making mistakes applying formulas and using negative numbers. But it has to be, since this is 1.8, this distance is a little more. It has to be 2.2 in this case. How about from negative 1.9 to negative 3.7? Well, that's around negative 1.8. So it really is a difference between 1.9 and 3.7, just 1.8. And I put a negative there, which doesn't belong because all distances are positive. So that's a distance of 1.8. All right, so here's D. Let me write this up here. I've got 1.8 squared plus 2.2 squared equals to D squared. And let's see, this is going to be 3.64 plus 4.84 equals D squared. Add those together. Whatever it is, 8.48. I think 8.48. I want to check myself on a calculator because I don't trust myself fully. First of all, 2.2 squared, is that 4.84? I think it is. Yes. Plus 1.8 squared is 8.08. Uh-oh. I see my mistake. Sorry about that. That should be 3.24, not 3.64. All right, so word to the wise, check yourself on a calculator. All right, 1.8 squared is 3.24 plus 4.84 is 8.08. Okay, so there we go, 8.08. So the distance is going to be the square root of that. The distance is the square root of 8.08, which is approximately, I'll just go ahead and calculate it, 2.84. 2.84. All right. Does that seem reasonable? It does to me. So that looks like a reasonable answer. Well, there you have it. You may have seen this before, but I'd like to give you a little more background on all this stuff, and throw in a little bit of history once in a while when a chance arises. I think you should have some sort of appreciation for how math is developed. It's not just this, sterile set of rules that people put in textbooks to torture students with. Actually has a very rich, interesting history on how people figured things out. And but it really did not occur to mathematicians that I'm aware of to even think about measuring distances any other way until the early 1800s. And so, but this is how we would measure in 2 dimensions. And then we'll see an application of this coming up very soon.